Okay, let's talk a little bit about DC versus AC. Yes, I know it's a rock band, but in the terms of electricity, these are two different ways that you can deliver electrical power to your home. The difference between the two is how you generate them. DC is generated by a battery. DC stands for direct current, and it indicates that current only flows in one direction. AC stands for alternating current, and alternating current is produced by generators which are used by ComEd and your local power utility. So if you take a look at the top circuit, this is a circuit that we've worked with in class. On the left-hand side is a battery, and a battery will basically drive charges in one direction through the circuit. So for that reason, a battery is considered to be a DC voltage source because it only pushes the charges in one direction. Also, if you were to look at a graph of voltage versus time for a battery, you would find that the voltage does not change, and the voltage is constant as time goes by. And this is exactly what a battery does. So this is the type of voltage supplied by batteries with constant voltage. Now, in your home, it's a little bit different. The voltage that comes from the ComEd plant or your power station is alternating. That means it changes. And so it's called, this is VAC, AC standing for alternating current. Now, this particular push is more like a push and a pull. And so charges will be pushed back and forth in the circuit. And that has to do with how the voltage is generated. But amazingly, it still results in work being done in your home, and you can still run appliances and do things with this type of current. Now, words that are used by electricians are the words hot and common. And the hot side of the voltage is the side that you have to be careful of, and that can go up to 110 volts. The common, or the neutral, is the side that's kept at 0 volts. So this might make a little more sense if you look at a graph of voltage versus time, and you would see for VAC that the voltage actually changes, and it follows kind of a sine wave type of a shape. So the voltage goes high and then low and then high and then low, and this happens at about 60 hertz, so about 60 times per second. And this is the type of voltage that's supplied by your outlets, and as I mentioned, the frequency is a standard 60 hertz. So from the point of view of thinking about circuits, from our point of view, it doesn't really matter what type of voltage we're talking about. So when we work on this project, you can think about voltage as just being some difference which provides the potential energy that you need in the circuit. But you should know that when you get voltage from an outlet, it's actually not the same type of voltage as you get from a battery in the sense that it changes. And so this is a little explanation as to why that is. Okay, let's talk a little bit about ground wires and GFCI devices. Okay, and this actually is all about safety. So let's talk about, for example, a case where this nice stick person might be standing next to a washing machine. Okay, so here's the washing machine, and inside of a washing machine you have an electrical motor. The motor is what, shakes the basket and gets the clothes clean. And so I'm going to represent that motor with a resistor. Okay, now let's put our voltage source over here on the right side. We've got 110 volts and 0 volts, and we're going to make our connections to the inside of the washing machine. Okay, so this solid line shows the hot line. The hot line delivers the current. It oscillates back and forth, and the dashed line is going to be the common line that allows us to complete the circuit. So if you look at this, we have a complete circuit. We have a voltage source on the right, we have a resistor on the left, and we've got wires which connect them. Now, in a perfect world, everything should be fine, and you should be able to run the system and wash your clothes and be safe. But let's say that inside the washing machine that a wire comes loose. Okay? Let's say that this top wire comes loose and it touches the metal body of the washing machine. Okay? So you've got a voltage here which is now in contact with the sheet metal of your washing machine. Well, I hope you can see that this is going to cause a problem, because what's going to happen is that the charges which are being pushed and pulled are going to be pushed and pulled, but they're going to follow a different route. Okay? Instead of going back through the intended route, they're now going to go through you, and you will complete the circuit because you're standing on your basement floor. Your basement floor is at 0 volts. So electricity will find its way to 0 volts, but it's going to go through the person. And this could be fatal. If you walked up to a washing machine in this condition and you touched it, electricity would travel through your body into the earth, and you could die. So what do you do about this? Well, one thing that's done is you add a third wire to your device. It's called a ground wire, and here it is. Okay? So this is a wire which actually physically connects to the sheet metal or the outside case of the appliance. And the idea would be that if a wire breaks inside, the current is going to have an easier way to get to the earth. It's not going to go through your body. So watch what happens here. Now, if you have a broken wire, what will happen is the current will flow, and it will flow through the sheet metal, but instead of going through you, it'll take the easier path, and it will follow this nice conductor which leads it to ground. And so you won't get shocked as a result. Now, you might wonder what happens next. I mean, a lot of current's going to flow through, and it's going to flow into the ground. For one thing, your washing machine is not going to work, because you'll notice that no current is going through the motor. So what will happen is that there's going to be a really large current that surges through, and a circuit breaker is going to open the circuit somewhere else in your house. And it's going to shut this off, hopefully after about 1 second of operation. So the important point is you're not going to be killed. What will happen is that the washing machine will basically stop working because the circuit has been opened by your circuit breaker, which is someplace else, in the house. And that's the purpose of a ground wire. So if you ever look at a plug, I'm looking over here, a plug actually has 3 different slots in it. It's got a short slot, a long slot, and we'll talk about those in a few minutes. But this round one, that's actually the ground wire. And that's that third wire that connects to the body of the washing machine. So that's a very important plug. Sometimes people think they want to bypass that plug, but that's not a good idea because you're actually bypassing the ground. This is the safety feature on the appliance. Okay, one other safety device I'll talk about. We're not going to use this in this lab, but I just want to point it out. You might notice that sometimes in your bathrooms at home, maybe in your kitchens, you'll see outlets that have test and reset marked on them. This is called a ground fault circuit interrupt outlet, or a GFCI outlet. And the way it works is pretty neat. What will happen is that you normally want current to flow basically through one side. Current going in is this way, and the current going out is going to come that way. Okay? So when you plug something in, whatever current flows through one of these slots had better be equal to the current that's flowing through the other slot, because all that current should be going through an appliance and coming back and completing a circuit. Okay? So normally, the current out and the current in should be the same. Now, what happens if you are working in the bathroom, or you're in the bathroom and you drop a hairdryer into the bathtub? Well, what's going to happen then is that the current that goes in to the hairdryer is going to flow out, but it's not necessarily going to flow out through the outlet. It's going to flow out maybe through the pipes and through the water. And so in that situation, the current that's going out is going to be less than the current that's going in, because some of that current is going through the wrong place. A GFCI outlet actually can sense the difference. And if a GFCI outlet notices that the current going out is different from the current going in, it's going to open the circuit. And it's going to do that really quickly. This happens within a fraction of a second. And a GFCI outlet actually protects you from electrocution, because it's supposed to open the circuit quickly enough that you won't have a heart attack, if you were getting a shock from this electricity. So the way that works is that there's a little circuit inside, and it's quite interesting, but I'm not going to explain the technical details of it right now. So what do you need to know about this is that you should just know that this type of an outlet basically compares the current going out of the outlet to the current coming back in. If they're the same, everything is good. But if they're different, you're going to have a situation where this will immediately open up the circuit. Okay? These types of outlets are usually placed near places where you have water in your house. So bathrooms and kitchens are quite typical. Okay, then I'm going to stop with this one here.